This tutorial is how to use the 3D visualization program to show the grid cell structure of the model. The 3D visualization program is available in both the preprocessor and also in the 2D, 3D grid display utility. In this tutorial, we will look at the preprocessor using the 3D visualization program. So in preprocessor, we will open a data file, and I'm going to open one that is in the samples folder v42.dat, and open up that file and display a modify grid cell values and show a grid cell parameter. For example, porosity is a parameter I can choose to show, and that shows the porosity parameter. Now this porosity parameter is a 2D map, and we can, as you know, we can go and show different cross sections in one layer at a time, or one XZ or YZ cross section at a time. If we choose the display 3D window, BTK 3D new, and we can choose to show a 3D picture of this cross section only, or we can show a 3D picture of all cross sections. Let's choose this option for now. And say yes, let's update that. We have nothing much to update, I haven't changed anything, and this form comes up. And for large models, we can choose to show one single cross section in the XZ. For smaller models, we can choose to show the entire model, and we're going to do that in this case, or the entire model. Choose all cells and display, and that shows us a 3D picture of the model. So in order to rotate or move the 3D picture around, I hold my left mouse down and just move my mouse around holding the left mouse down. If I use my right mouse down, I can move up and I can zoom in and out, and it's the same as using the scroll bar. Using the scroll bar on the mouse, you can rotate the scroll bar, the wheel, scroll wheel, and the wheel will change their zooming up and down. If you hold the control key down, let's say if I hold the control key down, I can rotate the picture around a focal point. If I hold the shift key down, I can slide the picture left, right, up, down, but not rotate the picture. So hold the left mouse down, you can rotate the picture of that thing. To see a cell value, if you click on the cell value, hopefully you can see that cross here. That cell value is identified, and the value is given at the bottom of that 3D picture. So it's possible for us to make cutouts or make cells active, inactive. Before I do that, I'd like to show you I can change the layers. I can change the layers 2, 3, cross sections coming from the top down, from the bottom, from the left, from the right. And so we can cut down the size of the model simply by that. If we go cross section, we can reset the display range back to the full model, and just I can reset to the save camera settings, which is the original position of the model. So if I do a cross section, I can select a certain line or row. So let's say XZ at current Y. So if I click here, cross section XZ at current Y, that will be that row. And then you can move the space through that row. You can move cross section YZ at current X. So this is around a column. And again, you can shift the column. Or I can also select, say, a layer. Click here, layer 2, XY layer 2, and this is layer 2. I can go back to layer 1, or 2 and 3, so I can choose my cross sections quite easily. Let's go back and show back the full model, display range. You can show perfect locations. You can show in Z, entire Z, all the layers at each vertical well. Okay, and let's go back and show the full model. Now in this model, we may want to make some cutouts. So for example, if I want to shift key down, push it up, if I want to make a cutout, I can pick from. This pick from essentially sets up one corner, and I can set for all layers. That means for all layers at that pick point to another corner, let's say another pick point around here, for example. So given that that rectangle of points for all layers, I can make the pick invisible. There we go. So now we can make a cutout through this invisible. If we choose to, we can invert the picture, so we can display showing visible cells, and that picture is inverted. We only show the invisible cells become visible, and vice versa. So we can invert the back, and this is the picture for the invisible cells. And this invisible cells is only a temporary feature. If I were to close the form and come back to it again, this invisible cells will not be there. We would have to redo it again. So in the preprocessor, there's an array, a grid cell parameter. Let's close this thing. A grid cell parameter. So let's create a new window, create a new grid map. This is a parameter called 3D visible cells array. This will give you a more permanent selection of the invisible cells. So let's OK for that. It says 1 for visible, 0 for invisible. So now I can have two windows, and for the 3D visible cells array, if I can choose to, I can make a range of cells. I can do it for all layers. For all layers, make that 0, which is the indication for invisible. So this is all invisible, 0. I can choose to make that invisible, that line invisible, that row invisible, for example, and save the modified values. Yes. Now under display 3D window, to indicate 3D, all cross sections, say yes, sure. And then in this one, if you now show that, we will now see our 3D picture with the same cells, and this will be saved in the grid cell data. And if you come back and redraw the 3D picture, you will always see this invisible cells. They're not inactive, they're just simply invisible for the purposes of the 3D display. Again, in preprocessor, if I have multiple windows, if I click on this window, it updates the window to the 3D window to the current active 2D window. If I choose another window, a new grid map, and I choose, for example, my explainability array to show in this grid map, and then I also see that this is showing in my 3D picture. If I choose my porosity window or my 3D active cell window, so whatever is the current active window, that is the window that the 3D window will show. Okay. So this is a tutorial on the use of the 3D visualization for grid cell parameters in the preprocessor. And in the other tutorial, I will look at the 3D visualization for the post-processing, showing pressures, saturations, and so on. Thank you for your attention.